Okay, so it's past 10 and I will switch to English as well for our international audience. So welcome to today's webinar on the 3D Bridge module in FEM-Design. I hope that you can see me and hear me. Okay, I got a thumbs up here. Not muted. So the topics of today will be a basic level introduction of the module. So this will be great for those of you who are not super familiar with the module. And we will talk about what it is, just very basic. We will talk about all of the available features, describe what I would consider a good workflow, and then I will show you guys one like simple practical use of a bridge. So some practical information for the webinar. This is recorded and will be distributed to all of you afterwards. And you can also get the FE model that I will use in the presentation. Just ask me on email. Please type all of your questions using the questions option in the Go to webinar. And also note that nobody else can see your questions. So there are no stupid questions. Nobody will laugh at you. So please just type any questions. You're usually not alone in your thinking. And I will probably not answer that many questions during the webinar. We'll see how the time ends up being. I will probably not run for the full hour also. So if you have something at 12, you'll probably be able to make that. But I will do a send out with a written Q&A of all the questions that you provide during the webinar. So first off, who am I? Why am I talking about the bridge module? Well, my name is Alfred. I'm a civil engineer based in Gothenburg, Sweden. And since June of this year, I am the product owner of the 3D Bridge module in FEM-Design. So what this means for you guys is that for anything related to bridges in the FEM-Design software, you should contact me, and you have some of my contact information here on the right side. And also, if you would like a trial license for this module, just scan the QR code and it'll take you directly to the sign up page. Yeah, just a quick note that I have several years working as a bridge engineer in the consulting industry. So jumping straight into the software, what is 3D Bridge? And to start us off, I write in parentheses that it equals the traffic load module because 3D Bridge is basically this button right here in the load page in the FEM-Design software. But then there are many options inside of this button, but it's actually just this button. If you have the base version of FEM-Design, you have access to all of the other options except for this one on the loading page, basically. So it's a licensed module, meaning that you need a specific license to use this module. Again, if you have the base software, you can have many other functions, but you need a specific license to use the bridge functions. And as I say, this is like a bridge focused module designed specifically for bridge design. First released in 2023. So a little bit more about the background. Some of you may be familiar with this moving load application, which can do, you could say, similar but more basic things compared to 3D Bridge. But it had big limitations for bridge design, and maybe specifically for vehicle, like car traffic roads. You could not handle more complex load systems, such as variable axle length. You could not handle more arbitrary load regions, for example, based on influence graphs, such as the software uses. And it required too many load cases because you had to do a lot of manual work. There were too many load cases, and of course, even more combinations, that it made it very cumbersome to use for actual design. But it does have a good base. It has some nice features that we can use in the 3D Bridge module. And I will talk more about this in just a second. So when the 3D Bridge module was designed, these were some of the main goals. And again, these are hopefully well directed towards the bridge engineer. So we want traffic load modeling that is according to Eurocode, and of course the various national annexes that you have. So we want to do LM1, LM2, and so on vehicles, which means that we need to have several bogie systems placed at the same time on the bridge, for example. And this was very difficult in the moving load. Yeah, we want the variable vehicle definitions, pretty basic stuff. We need to have several lanes, also very basic, but this was tricky to do in moving load. It should be easy to get maximum minimum envelopes for traffic load, because of course we get so many load cases that the envelopes is really what we want. Then a special goal was to get a good way to visualize the critical load positions for vehicles. And I will show you this later as well. And then an overall goal, I guess, was to have a good workflow in creating many traffic load cases. So this is again like a basic overview, what you might expect to do in the module. So you have your inputs, which is various properties for the traffic load, for the lane geometry, for the area that you place the load on. And then you pick a search algorithm. And here you have some great options to optimize and customize your analysis for the phase that you're in the project. And you pick your results, again, to optimize the time it takes to calculate. And your output will be a number of influence lines or graphs, depending on your geometry. You get traffic load cases, you get this visualization of critical traffic load positions, and you get envelope results for traffic load. So let's dive a bit deeper into the different features. So when you are doing the traffic loads themselves, you have two options, basically. You can choose from an existing library, which would look something like this. You basically open up this option, and then you have, depending on your country, you have various options to choose, and you just implement the vehicle immediately. Or if the vehicle isn't available in the library, you go to the edit library tool, which looks something like this. And this is actually what the vehicle would look like if I create this vehicle that we see underneath it. So you have all of these options, and you basically go from one direction to the other direction. So you add a distributed load, a distance, a concentrated load, distance, load, and so on. And then you get this pattern. And then a neat function is that you can then save this. And then it will be permanently added to your traffic load library, meaning that the next time you open a new project, the load that you created will be available in a new project. So even if you have very specific loads, you should only have to create them once. And I can also mention that the library that you get from the start can vary depending on your country. For example, in Sweden, we have a lot of the national special vehicles, but depending on your country, it could be missing. So in that case, you can always contact us and you can get some help, or if you can create it yourself, then you can send the file to us, and then we can distribute it to other designers in your country. Moving on to the lane geometry creation. So what you do is, let's say I want to create a geometry like this, 2 lanes. So you always start with selecting, if you have a surface, you select the surface and you create your stakeout line, and then this will be the base. And inside the module, this is the option that you get, and you can create as many lanes as you want using these coordinates, which are again based on the stakeout line. The loads are always placed perpendicular to your stakeout line. There are some limitations here, so the stakeout line cannot intersect itself, and it can be any number of straight lines. So here, for example, I could draw lines that go like this, and the software would accept that. But you cannot use curved lines, so they must be converted like this into several segments of straight lines, and then you simply draw your stakeout line along these straight lines. So for the search algorithms, we have 2 options. And I think the algorithms, it's especially important for bridge engineers, again, because we have so many load cases that optimization can go a long way. So you have brute force and multi-start. And when you use the module, you get an option that looks like this. You select brute force and a number of positions along the stakeout line or multi-start. And to simply show you guys how these algorithms work, the brute force is a discrete algorithm, so it only checks a number of selected points. In this case, we would get 20 points along, and here you can think of this as like the MX results for a beam, for example. The red line would be the real moment results, and then we use the blue dots to look for the real results. So then the algorithm would find a number of these points. So you can see that we find many of the results. Here we have the global critical value. With brute force, we get close, but we rarely find the actual critical point. So that's good to keep in mind. The brute force algorithm, because it's simple, it is quite efficient in the time it takes to use. So this is a good idea early on in your project to use brute force. Simply get a good idea that your model is working as you want. And then we have the multi-start optimization, which is a continuous algorithm, which means that it works basically like what I've try to draw here. You have a starting point, and then the algorithm expands or searches downward or towards your local maximum from that point. So with quite few points, you can find a lot of the critical values. However, they are only local critical points. So in this case, we actually completely miss the global lowest point here. So this is good to keep in mind, again, to maybe start brute force and then move into multi-start when you're in your later stages. And I want to talk a bit about the influence graph system. So I think some of you already know, but when in the moving load module, what you basically did was you create a or it's actually the same way that 3D Bridge works. You create your traffic load, and then the software will automatically create all of these load cases with a 1 kilonewton point load in this type of grid pattern across your surface. And the point of this is to generate a bunch of influence graphs. So in this example, for this 1 kilonewton point load, all of the red area here means that any traffic load that is placed in this area will be unfavorable, and green areas are favorable. So when we move into our envelopes, we don't actually need to place any traffic load in green areas. So this will create an efficient solve algorithm. Yeah, so the point of this again is to create the envelopes for traffic load. I'll show you this in a minute. So to say something about the visualization and building on the previous slide here, if we have a influence graph that looks like this, what the software will create in terms of traffic load, it will place the load like this, for example, if we this influence graph. So this can be very useful to visualize the patterns that are critical for your project. Here you can do this in real time. If you have your model open, you can move your cursor around the surface, and the software will in real time adjust the visualization to show you always the critical pattern for the node that you're in. So here I moved my cursor to the bottom point here, and then you can see that the new traffic pattern is based on the influence graph that was created with the point load system. And then I wanted to give a brief description of the workflow that I would recommend in 3D Bridge, because it can be a bit tricky in the beginning. And I will show you this more later on, but you want to start by creating a prototype traffic load geometry. And in this case, it's actually not important the specific traffic load that you use. What you want is to get the influence line created, the influence graph. What you then do is you multiply, you basically copy this pattern, and you place a bunch of different traffic loads on top, so you get many different results at the same time. Then you want to move into groups and combinations to get the arrangement that you want for your analysis, and then you run the analysis. So that's the end of my slides, and I will move into the actual case here. So again, this is quite a simple project. It's just a bit skewed like shell model, a simple bridge project. And all of the geometry is done, as you can see, but I have no loads at this moment. And I would actually recommend you guys in the beginning to start with your load case page empty. And instead, what you want to do is start in load groups. And if you didn't follow that, your load groups up here. Because here we have the exact same functionalities for as in load cases. We can add cases, but more importantly, we can add groups. So what I always start with is I add a bunch of groups, which will be used for many different reasons later. And we can permanent. So I will place all of my permanent loads in here. And then we can create this and call it variable. We can actually create another group, which are traffic. What you can do right from the start in here is to set up some of your logic that you want to apply to loads in these groups. For permanent, we set the type as permanent. Oh, actually, I can maybe save the logic until later. I will just show you how to create some load cases first. So in my example, I will use some dead weight of the structure. For type, you have to go in here and create the plus sign plus structural dead load. The plus sign means that the software will automatically apply the load in your model. I will create a pavement load. I will create a case for wind load, and then I will create and this I will call a test. So this will be my traffic load. So then I select the test case, and we move into the traffic load module. Here I have two options to either create a line model or basically a surface model. In this case, we want a surface. So I select the surface, and then I select my edge points for the carriageway. And now we can set the parameters here. We don't want bar results. For the speed of calculation here, I will uncheck simultaneous results. We'll use the same name for the loads. Here in load model is an interesting part for you guys. If I simply click here, I get these options, which are pre-made traffic loads, many different types of combination. If I, for example, choose the LM1 UDL unit here, oh yeah, it's I want to use this one actually. And I apply a factor, I select pane, and I select the priority here. And this is basically just a dummy case. Later on, I will create my kind of real loading cases. If I wanted to edit to create custom-made loads, I would scroll to the bottom of this and then I can create any type of vehicle that I want. I want no load modifiers. I will use a simple 2-lane system, one left oriented, one right oriented. For calculation options, let's go with the simple brute force 20-step alternative. All right, let's delete this. So now you have your traffic load placed on your structure. Not only that, you also get all of this load cases with a single unit load placed on your structure. And this is why I recommend people to stay away from the load case option, basically, because you get overwhelmed with all of these load cases. But from load groups, you can easily maneuver around this. So now I go back to the traffic module and I create this tool, the mass generation. What this will let me do is to select an existing traffic load pattern, and then I will copy the influence lines. But now I can choose any number of traffic load of like pre-made traffic loads that I want to investigate. So for this case, I can use LM1, LM2, LM4, for example, and then I create the results or select the results that I want. And you can get displacements, reaction forces, and then I also select. So all of these load cases will be created and automatically placed inside of this load group. So that's why we start in the load group menu. Then I get to choose right away traffic in this case. I click generate load patterns. And then we get 16 patterns, which is of course all of these results for all of these. Okay, I accidentally got this one as well, but that shouldn't. So if we go into load groups, once again, we have a long list of the test load cases, which are not interesting to us. You can just minimize that. And then we see that inside of the traffic load group, all of our traffic vehicles are placed. And this will be very useful when we want to get envelopes for traffic load. I will create some of the other loads. For payment, I create a surface load. Let's go with 5 kilonewtons distributed over the whole surface. I'll create a simple wind load, 2 kilonewtons. Place it. Oh wait, I should be in the line mode, of course. We created. Okay, now I made a direction mistake here, so I erased that. I will try. So I want this in the Y direction, of course. Okay, there we go. And these loads don't matter so much. It's just I want to show you the combination process. Combination tool looks like this, and here you can do any combination that you want. What I really like to do once I have set up my load groups in a smart way is to use the generate option. Before I do that, I will quickly go and double check my grouping logic here. So for permanent all of the loads in the permanent group, I will select this logic, which means that all of the loads inside these groups are applied for all the other options, basically. For variable, yeah, it's only wind load in here, but for variable loads, you generally want to select the alternative, which will, shift between the loads inside of this group. For traffic, we have the same case. We want to use alternative. We don't want to place, several traffic load patterns on the bridge at the same time. Temporary here. So now I should be able to go into the combinations option. I go to generate. And now I select the loads that I want to combine using the object that I created. These loads are of course not interesting for me, so I don't include those. I use my traffic loads and the permanent and variable loads. We're not really interested in these. We're just looking at ultimate limit state. And another good tip here is to actually uncheck this box, because it means that for every combination you create, you get a line of text that will show you exactly which loads and which combination factors are used in that combination. So then you can easily see that you have the right factors. So I click OK, and then we get all of these load cases. And again, we can see that dead weight plus pavement is included in every option. I guess the wind also, since we only have the wind load in the variable loads, but otherwise this would change, of course. And then we have one load case for each different traffic load pattern and result that we requested. So this seems fine. Let's go to the separation. And here I will just accept the suggested level of detail. In analysis, I will pick load cases, I will pick load combinations and maximum of load groups. And then we run it, and hopefully this won't take too long. I will just see if there are any questions so far. I have a comment saying not clear screen. That's unfortunate. Hopefully it's not too bad for you guys. I think I can't do much about that actually. There's the question, can we get a recorded session? If you mean this one, then yes, I will distribute the recording to everybody. There's also a question, can you share the FEM model? Yes. Please just use the email from the beginning of the slides and ask me, and I will send you any model that you want. Should be just a few seconds here. Okay. So let's go look at some results. The most interesting part, I think, for you guys will be the maximum of load groups when we look at our traffic loads specifically. So we will look at the moment in X direction. Scaling here. Okay, so here, if you want to get the visualization, you go to load generation, you click the plus sign here. Let's have a top-down view. And now you can do this. Now it seems like the critical load is kind of the same, but this is it's a too simple model. I think if you have a more complicated model, then you would get patterns that looks more like this, you know. But I still think that this is a really nice and appreciated feature to easily be able to see the patterns. And this is an envelope from the load, the traffic load cases. So look at your load combinations here. We'll go to shell internal forces and MX. Again, here you can see exactly what goes into your combinations, so your factors and all of the different loads. Let's just pick this one. Yeah, maybe they're not that interesting. Yeah, and then I think a nice feature of FEM-Design is how easily you can export all of your results, all of your visuals into the documentation program here. Now, I don't have time really to go into this module today, but hopefully in the future I can show you how easily you can create really nice results. Someone asked if I can share my email again. I will distribute this presentation to you guys so you can find it afterwards in the beginning of the slides. I think this is a good place to start, actually. I won't complicate things further. This will be just a simple outline of the software. We went through the basic workflow, and then, of course, there's the final layer, how you handle your results. But I think you have to try that out for yourself to see how it works. But I think you can see that using this load grouping system will get your results nicely arranged and easily digestible. So yeah, I'm just gonna take a few minutes here and look at some final questions, and otherwise, like I said, I will be back with a written Q&A with all of the questions and send you guys the presentation. And for those who don't have further questions, thank you for your attention.